Now we're going to move on to our final part of the tutorial before tips and tricks, which are inverse functions. As we said, inverse functions again are just more complex forms of functions, and it's simply the same function but we're finding its inverse. So how do we find an inverse? Now, the finding inverse functions can be done in 3 steps. First of all, you need to understand what an inverse function is, and then you can do the steps. So inverse functions performs the opposite operations to the function. In other words, when we think of mapping, what we did is we had our x and we had our y's, and every x led to a y. What we're doing here when finding the inverse, we're making every y lead to an x instead, and this is called the inverse. In other words, and the way we represent inverse functions, by the way, is that we put the function here with a -1 or negative, 1. Yeah, and then that's it. This is how we represent the inverse function. So what we're doing is we're taking it in a normal function and x leads to a y. What we do with an inverse function, we make that y lead back to the x. So if we want to find the inverse f of inverse x, we know that x is going to lead to y. So here where x leads to y, and then we're leading it back to x. In other words, this will lead to x. And similarly, if we find the inverse, so we're leading from y to x and we're taking that x back to y, then it's going to be giving us the same point we started with. This is a general rule for inverse function that you really need to memorize because it's important and you put it into use a lot. Now, before getting into all this mess, let us visualize what an inverse function is. Actually, let me tell you the steps first. It's going to make your life easier. So first of all, let me give you an example. So if I told you, here's a simple example, y is equal to x plus 4. What is step 1? 1, switch x and y. In other words, you're not switching, you're just, you're rewriting it but with your x instead of your y. You're doing nothing but just changing it. And then the second part is make y your subject. So what you're going to have here is that you're going to have your y actually equal to x minus 4. And then here, this is actually it. You solved it. This is your inverse function. Your y equal to x plus 4 became y equal to x minus 4. Here, this is your f of x, and this is here your inverse function f negative x. Now let me sketch both of these. As we said, we have, let's call them g of f of x and g of x. We said that y equals to x plus 4. That's how we started it here. And then that changed to x minus 4. So our g of x, let's put it in blue, is equal to x minus 4. Now let us sketch these. If we want to draw here our graph and we want to draw x plus 4, we know that it's a line of slope 1 and the y-intercept is 4. So this is okay. So if this is 1, 2, 3, 4, this is your y-intercept, and here it's 1, 2, 3, 4, and this is your x-intercept, and then that would be your line. Oh, let me just put it in pink so you'd relate the equations here. Now, if we want to draw the exact same line here for same thing for x minus 4, you know that here after 1, 2, 3, 4 lines, this is your y-intercept, and we're going to have the same distance here because it's x plus 4. And then that's the line. Now what is special about these is that the inverse is actually the reflection of the line in the line y equal to x. Now this is why if you actually put so here you just reflected one here, this line here onto this to get this, and you'll find that all these are always, this here is always equidistance between this and this when you take the perpendicular line, and this is how you know that it's actually a reflection. Now I want you to find, if I told you to find the composite function f of g of x, you're going to have to replace inside x the g. So here you're going to have x minus 4 plus 4, and that would lead you to x. Now if I wanted you to find g of f of x, you're going to do the same thing where your x becomes x plus 4 and you're going to take away 4, which leads you to x. And as you know, g is actually f of negative x. So if we want to rewrite it here, it's actually f of negative x, and it leads to x. And here we have f of negative of f of x, and it leads to x. And that would be the explanation of the rule I just gave you. And that would be the inverse function. So what you're doing here is that the inverse function, as I said, performs the opposite operation of the function. It takes y and produces x. And the general rule is that the f of inverse and the f of inverse of the f is going to give you x. And to find the inverse function, you're trying to make x the subject, and you're substituting x by f of the inverse x and y by x. And that was the example I gave you. Now it can be more complex than just linear functions. Then this is where you need to think harder. For instance, if I give you this example instead, here you have f of x equals to, okay, you're having f of x equal to 3 over x minus 1. So let's say y equals to 3 over x minus 1. As I said, the first step is to just make your y the subject in order to to flip the variables in order to make your life easier. And then you're trying to make y the subject of the formula. Here you're going to have x into y minus 1 equal to 3. And that would give you yx minus x equal to 3. Now, this seems like, oh my god, what am I gonna do here? How do I separate the y? This is why you do not do this step, and instead you're going to actually continue to say y minus 1 equals to 3 over x. And then you're gonna have y equals to 3 over x plus 1. Or in other words, 3 plus x over x. As you saw, the whole trick about the inverse functions is to know how to lead to that inverse. And this is what leads us to the tips and tricks, how to think of the solutions. And this is our sixth and final part of the tutorial, tips and tricks, and it's gonna be just a minute. So here we go. Oh, I want to add something here, very, very important, is as we said, this is our function here. If we want to find the domain, we know that x cannot equal to 1. And we know that our range here is going to be, we know that if we want to draw this is going to be x minus 1, so it's shift plus 1 here, and this will be our new asymptote, and it's going to be the same here, and our y also cannot equal to 0 because there's a 3 on top, and that's our range. Now, if we want to check for the inverse here, we know that x first cannot be 0 because the denominator cannot be 0, and we know that our range is going to be, and then if we want to find the range, we're going to figure out that the range cannot equal to 1. In other words, for f of x, the domain is the range of f of negative x, and the same thing happens. The range here becomes the domain of that. You flip the domain to range and it's going to lead you there. So if you can't find the range, for example, for this, it seems more difficult than it is, but it's actually just 3 over x plus 1. In other words, you have 3 over x, which is this is the graph of it, plus 1. That means your range is just shifting 1 to the top, and there goes. So y cannot equal to 1. That's your new asymptote. You're just switching range and domain. That was the final part. And now we can move on to the tips and tricks. And the tips and tricks I'm going to provide you are very, very simple. Now, as we said, we discussed mapping the domains and range and types. Domain and range, for them, the only tip I can give you, and the one you saw me doing over and over, is actually sketch your graphs. Sketching and illustrating for yourself makes your life a lot more easier, and it's easier than calculations, or it actually verifies your calculations. For composite functions, always think of f of g of x. When you're thinking of that, think of g of x as your new x, and that would make your life easier. If you just get confused, it's just ruining the whole thing for naught. Finally, actually for the inverse function, now as I said, it can be difficult. First of all, you can just switch and it will be easy. But sometimes it's not that easy. Sometimes you need to expand, and then you need to collect the expand and then collect the y on its own, which was what we did in the previous example, and it can get even more complex. Sometimes you have to actually use the quadratic function. you can have a quadratic equation and you're just stuck there and you don't know what to do. In that case, solve and find the x using the quadratic function the normal way. You can actually encounter different ways, and the only way you can remember them all is by practice. Solve and see every possible way you can come across inverse functions, and you'll be on the safe side. That would be it. Thank you for watching this C3 tutorial for chapter 2, and stay tuned for more.